In this starter, we're going to be reminding ourselves very quickly how laws of indices work. This could very much come up in your IB exams, in your end of year exams. Basically something more like the second question down there, maybe something like this, or maybe it's going to be an equation, but basically it's going to involve a combination of laws of indices. Now the first one, x to the power of minus 2 times x to the power of minus 3. What did you get for this one? What was your response for this? Excellent, that's it. So we add the powers, minus 2 plus minus 3, which gives us negative 5. X to the power of minus 5 is correct. Moving on to the next one now. Actually it says all negative exponents, so we actually have to simplify that even further. So now this is equal to x to the minus 5, right? But now they're saying, let's just actually get rid of the negative power. So how would we now rewrite this x to the minus 5 as something else? Remember, x to the minus n is equal to 1 over x to the power of n. This little cloud. So how can we use this little cloud there? 1 over x to the power of 5 is correct. Excellent, nicely done. Nothing to do with root here. What you're thinking of is fractional powers. That would be x to the power of 1 divided by n. And that would be the nth root of x. That is what you were thinking of. Can we stop singing, please? Thank you. Moving on to this one. 2 times ab to the power of minus 2. 2 times ab to the power of minus 2. Let's do it. Okay, so that's one way of doing it. So you're saying it's going to be 2 times a to the minus 2 times b to the minus 2, right? That's definitely one way to do it, but it says get rid of negative powers. Excellent, all correct. And now how do we put it all together in the one big fraction? 2 over? Excellent, that is 100% correct. Great. There was another way to do this, equivalent to what we did. So we could have said, oh, actually, that's ab to the minus 2. Let's use that property, that little cloud, the little bubble. So we could say this is 2 times 1 over ab squared. That's what ab to the minus 2 means. You can rewrite that as 1 over that thing, ab squared. And then you would just do the same thing as before. You could write it as a 2 over ab squared or 2 over a squared b squared. Basically equivalent, totally up to you which method you want to do. Right, moving on to C. How would you do this? 2 times a b to the minus 2. A over b squared is correct. Excellent. So let's move on to this one. 27 over 9 to the power of a. Now this is getting a little bit harder. They want us to write this down as a single power of 3. Yes, try. Excellent. How can you write 9 as a power of 3? And that is raised to the power of 8. Okay, now let's simplify the one underneath. 3 to the power of 2 to the power of 8. How can we rewrite that? Before we do anything else, can we simplify this denominator a little bit? Yes. Exactly. So 2 times a or just 2a. That's it. And now we can do the thing you mentioned about taking away the powers. So let's remember a to the power of m divided by a to the power of n is equal to a to the power of m minus n. And that's what we're using here. So it's what I just said, 3 to the power of 3 minus 2a. That would be a single power of 3. That is it. And moving on to the last one here, let's keep working with red. Everything needs to be a power of 3. How can we write a to 1 as a power of 3? Think about it. The 3 to what power gives you a to 1? Or is correct? Yes. Yes, we don't say kick in English, but I understood. All right, so 3 to the power of 4 and all of that to the power of 1 minus x. Great, and what about 9? 3 to the power of 2, exactly, and that's raised to the 1 minus 2x. Brilliant. Now we need to start doing more stuff. Remember now the next property we're going to be using here is a to the power of m. All of that raised to the power of n is going to be equal to a to the power of m times n. So that's the one we're going to be using here. So how do we expand the bracket here? 3 to the power of 4 to the power of 1 minus 4. Exactly. 3 to the power of 4 minus 4x times
9 to the power of 1.
Actually, we want to keep the 3 and we want to do something with the powers. 3 to the power of... Thank you so much, guys. And then finally, what do we do with these powers? We add them. 3 to the power of 6 minus 8x is correct. Brilliant. So that would be the final answer. That would be a single power of 3, and boom, we are done with this data. So this was a quick recap on laws of indices. Let me just start a new recording here.